Hello and welcome to the fifth activity in this Digital Leaders for Sustainability series. Now, this activity is all about using the amazing BBC Microbit, and in this case, the version 2, to help you to celebrate Walk to School Week. And what better way to think about how healthy we can be, how many steps we are taking, than creating a Microbit step counter. So that's what I'm going to be doing today, teaching you all how to create one of these. So why Walk to School Week? Well, Walk to School Week is for children, it's for families, it can also be for some of the staff in your school. There's lots of benefits of walking to school. For example, physical activity can help to improve our fitness and help us to stay healthy. It can also improve our mental well-being, so it can help us to focus throughout the day and also boost our mood. Very importantly, to digital leaders for sustainability, there is an environmental impact to walking to school. It reduces pollution, fewer cars, fewer vehicles emitting greenhouse gases means less pollution in the air. And also, with less traffic, there's less noise, there's less happening on the streets, which can also promote and support wildlife in those areas. Lastly, also worth a mention, Walking to School Week can support us in our safety awareness of how to actually think, how to navigate the streets in a safe and reasonable manner. Anyway, let's get started then with our activity of coding one of these Microbit step counters. Your first task is actually just going to be to get your Microbit out and get it put together. Now, this is my Microbit. It is the version 2. And you can see it's already lighting up because I've set it up with a step counter code already. When you put it together, you will need to put your Microbit on the front. You've got a battery pack that goes behind it, and it's all held together with this rubber strap. And then lastly, we've got the Watt strap, which is going to help us to strap this step counter to our foot. Lastly, you will need a micro USB port or cable, which is going to help you to get what you have coded onto the Microbit. So, when that's done, let's get started and move on to the second task. So your second task is you are going to start to code your Microbit. So in order to do this, we're going to go to BBC MakeCode, and I'm going to take you through a tutorial to develop this code for the Microbit sensitive step counter. Now, on your sheet, you will also have an example of what this code looks like, but I'm going to do a live tutorial which you can follow along and see the steps I am doing. So let's get started then and get coding this Microbit step counter. So the first thing I've done is gone to Microsoft MakeCode or makecode.microbit.org, and this is where we're going to put this project together. There's loads of tutorials for you to do in your own time and some special ones just for the version 2, as well as some follow along videos. For this project though, we're just going to start a new one, and I will call this step counter, and I'll just call it version 1 for today. We are going to look at how to challenge ourselves and make this even better as we go along. Okay. So this is what the interface within Microbit looks like. Over here, we have our script area, so where you're going to put all of your code and snap it together. We have our palette area, which is where we can pull out all of our different commands. And then over here, we actually have a simulation where our animation happens before we download it onto our actual Microbit. First thing then, with this Microbit, much like a step counter, I just want it to work when it is turned on. So on start, I am going to get it to show the number of steps and set that to 0. So it's really important that we are going to reset every time the device is turned on. Otherwise, it would continuously count from what we've done before. So to do this, we're going to go to variables, make a variable, call it steps, and we are going to set steps to 0 and show the number 0. And you'll be able to see my simulation come and start to work. Okay, fantastic. Now, if I was going to create a basic step counter, what I would want to happen is when the device is shaped, what I would want to happen is it would change my steps by 1, and after that, it would show number and show my number of steps. And let's see how that works. So if I click shake, it's going to start to count how many steps I'm doing. Now, the reason I'm calling this a basic step counter is because a shake is actually something you do with your hand. When we're creating a step counter which is going to go on your foot, it has to be sensitive and it has to be measured and think about the movement your foot is actually going to do. So instead of on shake, we're going to use the forever loop and we're going to use some logic to support us with this. So I'm going to be actually coding the accelerometer in the device to measure a certain amount of movement. And when that amount of movement is recorded, it's going to change the steps by a certain amount. So I'll just drag this code out. And then I just need to go to logic and use comparison to help me to put this together. So what I'm going to have as my input is I'm going to have acceleration, and I'm going to use the drop down and select strength. And let's snap this in up here so you can see it really clearly. So forever, if the acceleration of strength is going to be over, so greater than, and we're going to call this 1,500 because that's what we've decided is going to be mimicking the movement you would do with your foot. Whereas if I just shaped it in my hand, it wouldn't be picked up. So if it's over a certain amount, then it's going to change my steps by 1 and show the number of steps. So let's see. So now you can see in my animation, when I shake it, it's going to start to move. And this is only when I'm shaking it with a certain amount of strength. And you can see when I only lightly touch it with the mouse versus shake it really hard, it's going to adapt and therefore act as a sensitive step counter. Right, that's it then. That's your basic bit of coding done for the sensitive step counter. The next thing we need to do is get your program, get your file, and put it onto this device, onto the microbit, so we can start to run it. So the way we do this is when your microbit is plugged in, and you will know it's plugged in because it will light up. And if you are using a battery pack, make sure it's not connected at this point. And then you can use the 3 dots, connect device. Next, we're going to pair this device. And you'll see up here, it's saying that it's paired. So yours is likely not going to say paired. So I'll just click connect. And the first step, oh, brilliant, it has connected. So click done. And then I'm going to download. And as I'm downloading, you will see you get a progress bar on your screen, and then the code will be on our microbit. So if you want, you can have a little test like this. Okay, it seems to be working. Then I'll unplug it, plug in the battery pack, and then I can have a look to see if it starts to work. Okay, that's the first step. Well done. Have a play, and then we'll come back and see if we can challenge ourselves even further. Now, hopefully, you have now finished coding your microbit. You've downloaded it and you've tested your step counter. I hope you've been able to do that and find out just how well it's working. So let's move on. And in our next task, it's all about how you can challenge yourself further. So here's 4 challenges which I think would really test your coding skills and take this sensitive step counter and make it even better. So firstly, could you add a button control that reveals the step count only when the button is pressed? So when you use an input, can you make it that the amount of steps you've taken is the output? This would make it a lot clearer for you to be able to see the data on demand, and the microbit wouldn't have to keep processing in the same way and showing you as you go. Secondly, could you use the logging feature to record the number of steps taken on multiple journeys, and then use the analysis part to actually look into that and compare the results? Another idea: the step counter only registers every other step because you've only got it on one foot. So could you make it to double the results so then it will fix and record accurately? Now, the last way you could challenge yourself, and this is really a great challenge to think about, is to use the accelerometer on the microbit, and it can actually measure in 3 different directions. It can measure on an x-axis, a y-axis, and a z-axis, depending on how the microbit is attached to your shoe. So can you play with those different axes of recording and work out which is best for detecting your steps? Good luck with the challenges. For the next task then, let's look to add some challenge. So we've got 4 ideas here. The first, add a button that reveals the step count so you can clearly see it, and it means that the screen won't always be lit up, which will drain your battery. The next thing, can we add a logging feature to actually record how many steps are happening and then look at that data afterwards? Also, could we use our step count to register 2 steps at a time? Because if we only have it on one foot, it might not pick up on that. And then, can we use the accelerometer to measure movement in 3 dimensions? So X, Y, and Z axis. So this means wherever the microbit's attached, it's going to measure really effectively. Let's take a look at the first challenge then. Add a button that reveals the step count. So here, we'll go to input, and we will have on button B pressed, and we are going to have show the number of steps, and we'll just drag that out. So what will happen now is on start, set numbers to 0, show number 0, and on forever, it's going to start to change the steps, and then when we press B, it will show how many steps have taken place. So let's try that again. So I'm up onto 94, and we'll keep going and see how we go. What might make this even better, and what you notice on some different smartwatches, is maybe as you are running, you could add something like maybe the little flashing heart. And this could look really good. So as you're going along with your code, and as long as you're working, it's going to show that it is recording as you are moving. So that might be a really nice little addition for you. And on B, same thing, it's going to show the number of code that we've got to. Now, a really quick win in order to make it so it counts 2 steps would just be to change your steps by 2 instead. And that would be a really effective way of doing it. Now, when it comes to using some of the logging features, this is going to be more challenging. So what I'll do, I'll zoom out, and I'm going to have a quick look at how you can do this. So the logging feature, we would need to go to extensions, and we would need to choose the data logger. Now this is just for the version 2 microbit only. And what will happen now is when we start to record data using the data logger, then it's going to remember and store on the memory, on the processor of the device, how many steps we have taken. So that way we can actually view that afterwards. So the way we would do this is if I go to basic, on start, and variables, and I am going to put one to logging. So set logging, and then I am going to put set logging to false. So on start, set logging to false, and I'm going to show an icon. And the icon I'm going to be using is a cross. Okay, fantastic. So that's my code that's going to be going right at the beginning. Then after that, what I'm going to have, I am going to set some columns, and I'm going to set columns X, Y, and Z. Let's put those in. X, Y, and Z. Brilliant. Now I'm just going to actually take this code off on start, and I'm going to put it in an input A, and you can see it's all lit up now. That's because I just had two commands under on start, and I think they were cancelling each other out because they were both using variables. So what's going to happen on start, it's setting logging to false, and it's going to show the icon. So that means that we will not be recording anything. I actually need to tell this microbit to start logging. So the way we would do this is I need to, on button, well, we were already using B, we're already using A. So we'll use button A and B together. When that's pressed, I'm going to set logging to true. And I'm going to show an icon just to mean that I know this is happening. And I'll put a tick in. So that way, when we've got A and B pressed, it's going to tell me it's going to start to log, and you can get the tick. Now, right now, it's not logging anything because I haven't got it to start to record any of the data. I've just said set the columns X, Y, and Z. So what we'll put in, I'm going to use loops, and we could use 100 milliseconds. You could change this. You might use 1 second instead. It's just how often it's going to record the data. So I will put in if every 100 milliseconds, if the logging is true, so if logging, then go to data logger and log data. We're just going to add the plus because we need 3 because we've got an X, Y, and Z column. So X, Y, and Z. And then I'll go back to my input and I'll bring out accelerometer or acceleration, duplicate and snap it in. And I've got my X axis, my Y axis, and my Z axis. So what's going to happen, we've now got a data simulator, which is going to start to work. And when I download it, I'll be able to record that. So we'll press A and B, start recording data, and you can see it's recording it on the X, Y, and Z axis as we go. Now, what you would need to do here is you would need to add another button to stop recording the data. Otherwise, you're going to end up with the processor becoming and having too much on the storage, so it won't work. But that is a really nice way of using the logging feature so I can actually go and use the analysis to look at how I've been moving. And imagine if I'm recording that and I measure my steps one day, could I do it the next day and the next day and see which day I have used the most steps on? So there's some amazing ways to challenge and improve your code there using the logging features, changing the inputs, and also measuring using the different axes on the accelerometer. Nice work and enjoy these challenges. Well done and congratulations for getting this far. Now, I really hope you managed to challenge yourself and create a fantastic microbit step counter. Microbits are fantastic tools, which I hope you begin to use even more. As always, This last task is all about how to enhance your impact. Here's some ideas. Could you use this activity to lead a step counter code along? Could you challenge other children in the school, maybe even a different year group, and teach them how to code? Could you present the data you analyze to your class? So go in, pull out the data, and showcase that, and showcase your analysis to your peers. Look at some of the other Microbit resources, such as Explore the Microbit Playground Survey, and take that to your school. Also, can you encourage others to create a step counter and record their impact during Walk to School Week? So bringing it all together and looking at how you can use your Microbit to encourage others to be more sustainable.